In tonight's episode of Cybersecurity Degree for Free, we're going to dive right into real world troubleshooting with networking and how it can help you in your career as a cybersecurity professional. Without further ado, let's dig in. So the steps that you want to take whenever you're working on networking troubleshooting is a 7-step methodology that typically works, and they are as follows. Number 1 is identify your problem. You want to look for clues, ask questions, and do one of my favorite things, which is called the KISS method, or keep it stupid simple. So, and I love that phrase because it's like a military phrase. I'm prior service. When we hear keep it stupid simple, it's really, it reminds me of my time in the Air Force. You can look to see how wide the problem is, and if it's usually just one person or multiple people, it'll depend on how much digging you have to do. But to wrap that up, essentially, you want to focus on, for the very first thing, is identify your problem, because identifying your problem is, probably the simplest and easiest thing to do to start off with. And usually, it is usually very simple, but it can be quite complex. So that brings us to our next step, which is to develop your theory. Now, when you develop your theory, you're looking for, okay, let's say you think that there is a broken connection somewhere in your building and the Ethernet cable maybe got eaten by a dog or something. Who knows what happened. So the Ethernet cable that runs to some person's office got eaten by a dog. You want to test that theory out, and so you go take a look. You see if the Ethernet cable was eaten by the dog, and if it was, then you can prove that it was and essentially fix that and just put a new Ethernet cable in. So you develop your theory, you test your theory, but what do you do if the dog didn't eat the Ethernet cable? What if your theory isn't correct? Well, then you just go back to the drawing board and you come up with a new theory. Maybe it's something software related. Maybe that person can't connect up to the internet because they were never given access to the wireless network. So essentially, once you do have a test that proves positive, then you're going to form a plan of action. You're going to go do that thing, and then you're going to rule out your solution, and you're going to fix that thing, and you're going to give an example, and then you're going to go ahead and once it's fixed, you're going to verify that it worked. And then once you've verified that it has worked, you're going to go ahead and document any findings for future reference. And I can't stress this enough, especially whenever you're a professional working in the field. Documentation is huge, and it is definitely the difference between somebody being able to land a job and not land a job. Documenting your findings, people in the real world, they care so much that everything is written down and easy to find, so that way if something in the future happens again, they can go back and look for it quickly and easily. It doesn't always happen that way, but that's the way it should happen. And I can speak from personal experience. You definitely want to have good documentation. It makes a big difference in the way that people look at you and the way that you feel about yourself too. If you're good at documenting, then you can go ahead and feel good that if something happens to you or happens to somebody on your team or something, God forbid, you know that somebody's going to be able to be there to go ahead and take care of that thing. So the 7 steps are: number 1, identify your problem; 2, develop your theory; 3, test your theory, and if it doesn't work, look elsewhere and come up with a new theory; 4, once your test proves positive, then form a plan of action; 5, roll out your solution; 6, verify that it worked; and 7, document your findings for future reference. And that's how you troubleshoot a network. And if you follow that 7-step procedure, I promise you that 9 times out of 10, matter of fact, 999 times out of 1,000, to be more precise on those zeros, that is going to work for you. So, and I can speak from personal experience on that. Okay, so let's go ahead and start off with ping. As you can see here, I've already run it once on this machine. Let's start off with pinging 10, which we're on a 10 dot network. So 10.10.1.102. See if we get anything back. Hey, we got some response back for that one. So this is what you typically see from a ping command. You'll keep on getting the results back. Unless you're on Windows, it'll time out. On Linux, it doesn't. So we'll just hit Control-C to time that out. And then let's just run it again against another 10.10.1.103. See if we get anything back for that. Yep, and so we can see that something's alive on 103. And again, for 10.10.1.104, let's see if there's anything there. And so you can see right now, there's nothing because we're getting host unreachable. So we know that we have a 102 and a 103. Let's check and see if we have a 101. Yep, we have a 101. Okay. And so now that we know kind of how ping works, I'm taking a further step and do the man page for it. So when we do a man page, essentially we're just checking the manual of how that command works. And you can do this for any command on Linux. And so when you hit man dash whatever or man man ping or man whatever nmap, so you hit that and then it'll come up with the man page, and then we can actually start to go through this, and you just hit the enter key to go through. You know, you can scroll through it and take a look and see if there's something that you're specifically looking for. Like you can set it to only use IPv4, or you can set it to only use IPv6, audible ping, adaptive ping. Like you can get really detailed with this tool. However, most of the time you're only worried about using ping to see if something is actually going to respond. And you can actually set it as a network admin. You can set ping ICMP to not take responses, so that way your device doesn't actually show up when somebody is pinging it. Moving on to the next command, which is netstat. We'll just do a netstat-a. That's pretty common. And so you can see here, netstat's just going to show you all of your open interfaces. You can see there's a lot of stuff here. This is really when you start to get into like some detailed troubleshooting. And so the main point of netstat is used for displaying info about your active network connections and your routing tables. If we come down into the man page for netstat, you can see there's so many things you can do here. You can print your network connections, routing tables, interface statistics, masquerade connections, and multicast memberships. So we'll go back through this. This is an important point I wanted to mention. This program is mostly obsolete. Replacement for netstat is SS. So I mentioned netstat because netstat's pretty much on every Linux box. SS might not be, depending on how old the environment is that you're pen testing or looking at or troubleshooting on a network. So the next area that we're going to focus on is SS, and I'm going to do a -L to that. And so when we run SS, it is another utility to investigate sockets. SS is the replacement for netstat. And so whenever you're working out of this, you're going to just basically use SS when you're on a more modern Linux machine, but whenever you're on an older machine, you probably would just use netstat. The next area that we're going to cover is ifconfig. Ifconfig is going to give you all of your networking information. And if you watch my previous video, I go over this a little bit. And so right here, you can see this is just a loopback address, 127.0.0.1. And then here we have our Ethernet 0, which is a 10.10.1.100. This is our IPv4 address right here. Our IPv6 address, our net mask, and then our broadcast right there. That is essentially the areas that we're concerned with. We're really only concerned with this right here. So again, we'll run the man page so I can show you what ifconfig is really doing. Ifconfig is how you configure a network interface. Really, the only reason why that you need to use ifconfig is if you're going to go ahead and just try to get your IP address. But you can come in here and do more than that if you need to. You can set options and change. You can get more verbose information. That's ifconfig. And then the next is going to be what is basically a much more pretty version of that, which is IP address. Now, older machines don't have this, but newer machines do. And so you can see here, you get it back colored. So you can see inet is your 127.0.0.1 for your loopback LO, right? And then ETH0 or Eth0 for Ethernet is right here. So the same thing, 10.10.1.100. And we're on a WAC24 network. That is a very handy feature of that, showing you that you're on a WAC24. If you do ifconfig, it doesn't tell you that information. So very handy. I definitely prefer using IP address over ifconfig for that reason. So use it if you have it. If you're on a new version of Kali, you're going to have that. You're going to have IP address built in. So the next one that we want to be concerned with is traceroute, which will show you the path of a packet from your source to its destination. So let's do a traceroute, and let's just say 10.10.1.103. Let's see what happens. Okay. So it's going to tell me where it went. And this is better if you're not on a closed sandbox network. So I wanted to do a trace route on a machine that is internet facing, so that way you can see how this actually is supposed to look. And we're just going to ping Google DNS, so that way you can see, well, trace route Google DNS, so you can see. And on your screen, a lot of this is going to be blurred out, but just know that what you're seeing here is 1, 2, 3, 4, 5, 6, 7, and 8. You're seeing actually how the packets are hopping from point 1 through 8. Point 1 is my address, my actual machine, and then 8 is the final, which is Google DNS, and it's every step there between. Now, for security and privacy reasons, I'm going to have this blurred out, but just know that this is how you would see it, and if you want to try it for yourself, you can do the same thing on your machine at home, traceroute 8.8.8.8 or google.com or whatever, right? And so I'll show you one more time here with google.com just to show you that it does the same thing. A lot more hops you can see, but essentially you're getting the same thing. So for that one, it took 24 hops. So, and again, like I said, it's all going to be blurred, but it's just to prove to you that this is how your packets are actually flowing. So traceroute's a very useful tool for whenever you are doing network troubleshooting. The next is ARP. So ARP is going to show you essentially all the hardware devices on your network, and ARP is just, well, let's go to the man page and I'll show you. It is the system ARP cache, which is address resolution protocol, which is basically how you match up your IP addresses to your MAC addresses. So if I do ARP-A, I'm just getting back all the different ARP addresses that it can tell, right? So 10.10.1.102, and then this is the MAC address associated with that, and then 10.10.1.101 at this MAC address. And so real quick, I'll show you. Now in a normal environment, you're not going to have this, but essentially you'll have, like, this is an Ubuntu box. This is one of the boxes that it's seeing, right? And then here's a Linux Mint box that you're going to see. And so in a normal environment, you don't know that these machines are out there. You're kind of running blind. And then this is a VulnHub box, which we'll get to later. And so that's coming up. Hacking is coming up. So stay tuned for that. But essentially, this is just a vulnerability-ridden machine. So essentially, whenever you're in this, you're not going to know the login information. You're not going to know anything. This is a typical VulnHub box. So Mr. Robot, it's a good one. We'll dive into that a little bit later. Let's continue on with networking troubleshooting. And the next one is going to be an NS lookup. So you can see what that looks like. NS lookup is a program to query internet domain name servers, and it has two modes, interactive and non-interactive. So what we're going to do is we're going to go ahead and give it an NS lookup and then the name of the server. So we're just going to try NS lookup and then Google. NS lookup, google.com. So we can get all the information for google.com right here. And you can do this with anything. So let's just do an NS lookup for Microsoft.com, and you can see here this is Microsoft's information as well. So pretty useful whenever you need to know that information, and you can do that with any kind of server, knowing where that information is. Definitely a useful tool. And then we have dig. We'll do that for Google.com. And this is the same thing as NS lookup. Essentially, it's just giving you even more information than what you got with NS lookup. Again, if you want to do the same thing with Microsoft.com or something else, you could do it with anything really. Try hackme.com, and it'll give you all the information that it can find out there for these records. So looking at the man page for dig, this is what we get back. Dig is a flexible tool for interrogating DNS name servers. It performs DNS lookups and displays the answers that are returned from the name server. or servers that were queried. Most DNS administrators use Dig to troubleshoot DNS problems because of its flexibility, ease of use, and clarity of output. Other lookup tools tend to have less functionality than Dig, which is true. So Dig is the better version of NS lookup if you need to know how to use that in the future. And then the next one we'll show is going to be route, which will show off our routing table. On your screen, this is going to be blurred, where my personal information is going to be. But just know if you run this on your end, you will be able to see your personal information and know how your routing table is set up for your machine and for your network. And it's very useful if you need to know this information for your network troubleshooting in the future. The next tool is TCP dump, and I'll show you how that works. And you have to run this as sudo. So sudo TCP dump. So essentially it's going to look at all the network traffic that's happening over my internet and then give that back to me. And it's going to be a lot of information, and all this information on your end is going to be blurred, but just know that if you run TCP dump, you're going to see a lot of information for what's going on your network. It's very useful. It's like it's essentially a Wireshark that's built into your command line, but it's not as useful as Wireshark because you can break things down a lot easier. So I'm going to just stop that. But essentially, if you need to do something like that, if you're looking for something quick, you could do that, and you could pair it with something like grep and look for something specific as you're searching for this, or you could go ahead and pipe it to go to a log file. Like you could go ahead and create a log file, which would just be like a simple txt file, and then you could use grep to find certain things if you're looking for certain things. So there's definitely usability here if you're trying to run a basic network scan, but I think most of the time you're going to want to use Wireshark for something like this, since you're just trying to get all of the TCP dump information. The next thing we'll do is going to run Nmap, an Nmap scan. So Nmap is probably the best tool on this list. This is one that you're going to use a lot in cybersecurity and networking. It just is all-encompassing. So here's a typical one that you're going to run, ss-a, and then your network address, so 1.100 and a WAC24. And you can see here I didn't run it as root, so I'm going to go ahead and do that as root. Sudo nmap dash. We just go ahead and complete that. So all I did was hit the right key on my keyboard, the right arrow key. And so now it'll ask me for my password. This is just a standard Kali box, which the password on standard Kali boxes is just Kali, right, if you get it from their website. So now it's just going to do its scan, and it's going to essentially, it's going to look for anything on the network, and it's going to look for the operating systems, and it's going to look for open ports. And so I'll show you the man page for that in a minute, but this Nmap scan is going to be really useful, especially if you are doing a pen test, because you can see anything that might be vulnerable. Okay, so here we go. So this is anything that is on that WAC24 that's on this network right now. So let's scroll up to the top here so we can get everything. So ignoring all this stuff here, we can see 1.1 and ignored state. We don't really need to focus on this too much. 101 and an ignored state. Okay. And I believe that 101 is just our Kali box here. So it recognized its own self, right? 102 is in an ignored state. So we don't know much information about this. So all 1,000 scanned ports are in ignored states. 1,000 closed TCP ports. And then the MAC address, because this is only going to give us this virtual box, virtual NIC. This was a real production environment. We're going to get more than that. And then if we scroll down here, this is our vulnerable box, and you can tell because of how much information we're getting back. This is why it's important to patch your stuff and make sure that your stuff is locked down in a production environment. So this is that Mr. Robot box that's running 103 as its address, 10.10.103. And so we can see here SSH is closed, but port 80 is open. So, and then port 443 is open. So it's a web server essentially. And if you've seen Network Chuck's video in the past, you know that he's done this box. So essentially, if we were going to hack this further, we would have this information to work with. So we know that it being a web server, now we would start to do some web vulnerabilities and check for things like that, right? So running like a burp suite and checking against that. So very useful for whenever you go ahead and do pen testing in your career. So thanks again for all your support with watching my videos. I really appreciate it, and I hope you have a wonderful night or day or whatever time of day it is, wherever you live at. I genuinely appreciate your time, and I look forward to seeing you in the next one. Take care.